champ, how are you doing? Welcome into another amazing session and I'm your master teacher Shivam Gupta. So champ, in today's class, we're going to learn about the tangent and the secants of the circle and we will see some very important properties of this circle also. So make sure that in today's class, you're making the notes and you're writing every concept and every properties with me. So let's get start champ. So in today's class, we will see about the circle, the different part of the circle and some very important properties of this circle also. So champ, look at this one. In this one, we are moving a very particular path, right? And that path, on that path, every point is at the fixed distance from the fixed point, right? We can see that every point on this path at the fixed distance from the fixed point. So champ, the collection of these all the points, the points which are lying on the path, the collection of all these points are known as the circle, where the distance of all the points from the fixed point, which is known as the center of the circle, is same. So now champ, when we talk about the radius, so when we are saying that the distance of every point which lies on the circle are at the same distance from the fixed point center. So champ, that fixed distance, the same distance, is known as the radius of the circle, or we can say the line segment joining the center and the point on a circle is known as the radius of the circle. Now if I will join 2 points which lying on the line, right? If I will join a 2 point which lying on the line, then in that case, that line segment will be known as the chord of the circle. And if that chord is passing through the center, if that chord is passing through the center, so that chord will be known as the diameter of the circle. And we know the relation between the dia and the radius of the circle. That diameter is always the twice of the radius, right? So now champ, now when we talk that outer boundary of the circle, right? The champ, the total distance around the circle, the path on which we were moving on. So the total distance of that path is known as the circumference, or we can say perimeter of the circle. Now champ, when we say the circumference, and if I will take any continuous part of that circumference, or if I will take any continuous part of the circle, that continuous part is known as the arc of the circle. Now champ, let's talk about the tangent and secant also. So champ, tangent and secant both are the line and depends on their position with respect to the circle. Like the line and the circle can have 3 different positions. In the first one, there is no point of intersection between line and circle. That is why we say that line PQ is the non-intersecting line. Whereas in the second case, line PQ and my circle having 1 point of intersection. So in this case, the line PQ is known as the tangent to the circle, and point A is known as the point of contact or point of tangency. But it could be possible that my line and my circle are having 2 points of intersection. So in this case, the line segment PQ is known as the secant of the circle. And whereas A and B are lying on the circle known as the chord of the circle. That means if I extend my chord in both the direction, it will become the secant of the circle. Now champ, let's move on to some very important properties of the circle. So first one is, champ, let's say inside a circle, we are having 2 different chords. 2 different chords but of the same length. If we are having 2 chords of the same length, then champ, both the chords will sustain the same angle at the center. Does not matter what is the location. If 2 chords are same in the length, they will be sustaining the same angle at the center. And same we can say that if two chords are subtending the same angle at the center, the length of both the chords will also be equal. Okay? The next one, let's say if I am drawing a perpendicular from the center on the chord. If I am drawing a perpendicular from the center on the chord, then that perpendicular also will be the bisector of my chord. Or I can say that if from a line from the center is bisecting my chord, then that line must be the perpendicular on my chord also. The very important property, and we have to apply it in many questions also. The next one, let's say we know what is our collinear point. Collinear points are the points which are lying on the same line. Now, while we are saying non-collinear points, that means, let's say we have three non-collinear points. That means these points are not lying on the same line. So now, let's say we have three non-collinear points. So through these non-collinear points, we can have only and only one unique circle. And this is very important. Many times it has been asked directly also. And let's say if we have two chords of the same length, then if we have two chords which are in the same length, then the distance of these two chords from the center will be same. That means if two chords are there inside the circle, then the distance of these two chords from the center, perpendicular distance, will also be same. And same the vice versa. If two chords are at the same distance from the center, then the length of both the chords will also be equal. Let's say, in this case, if we are talking about any particular arc. Now, from the end point of that arc, we are subtending the angle at the circumference, and from the same end point, we are subtending the angle at the center. So, do you know what? That the angle subtending at the center will be twice the angle subtends at the circumference. A very important property, but make sure the end point will be the same. So now, let's say we are having two segments. We know that my chord divides my circle in two segments. So now let's say from the end point of any arc of any chord, we are subtending two angles at the circumference on the same side of the line. Then both the angle will be equal to each other. In the same way, if I will say that my line, right, which is subtending two angles, if both the angles are equal, then all these 4 points are coincyclic. That means all the 4 points will be lying on the circumference of the circle. Okay? Now, if let's say we are talking about the diameter. So we know that the diameter always subtends the angle 90 degrees at the circumference of the circle. And not only at one point, at any point, if I am subtending any angle at the circumference with the help of the diameter endpoint, the angle always will be the 90 degree. And let's say we are having a quadrilateral and all the 4 vertices of the quadrilateral are lying on the circumference of the circle. Then the quadrilateral will be known as the cyclic quadrilateral, where the opposite angles are supplementary. That means the summation of opposite angle will be 180 degree. In the same way, we can say if in any quadrilateral the opposite angles are supplementary, then my quadrilateral must be the cyclic quadrilateral. I hope you got it. So now, let's summarize what we have seen till now. So we have talked about the circle. The circle is the collection of all the points which are at the fixed distance from a fixed point. Then a line segment joining the circumference and the center is my radius. And the line segment joining 2 points on the circumference is my chord. And if a chord passing through the center will be known as the diameter, and any continuous part of the circle is known as the arc of the circle. Then we have seen that it depends on the position of line with respect to circle. We talked about the tangent, non-intersecting line and the secant. Don't forget to practice, stay tuned and be curious. Keep smiling. Bye-bye.